In this lesson, we will introduce another resource as part of our DevHabit application. This will be the user's resource represented by the respective entity, and as part of this lesson, I will simply walk you through the changes I made in the code in order to add support for working with users. You will see that all of this is very similar to what we did before, which is why I'm doing a quick walkthrough instead of writing everything from scratch. Now let's jump into the code and let me show you what I added. I recommend that you download the latest version of the source code, which will be available right under this video, as I've made some improvements to the code from our last lesson. If you open up the entities folder, you will now see the user entity, which is the class that I'm showing here on the screen, and this will represent our new resource. This is a very simple type. We have just an email and a name for our user, and we are storing some timestamps when the user was created or updated. I will also use a custom identifier for the user, which is why the value is a string. And then we have an interesting property where I added a comment, which is the identity ID property. Now this will represent the actual identity of the user within the identity provider system that we will be implementing. This could be any popular identity provider like Azure Active Directory, which is now called Entra ID. It could also be Cognito, Keycloak, Auth0, it doesn't matter. All of these systems will assign a unique identifier to the user inside of their system, and this is something that I want to separately store from the identifier of the user inside of the DevHabit system, which is why this entity has an ID property and an identity ID property. Another thing that this allows us to do is to switch out identity providers by simply assigning the correct identity ID and then implementing the connection to the respective identity provider. As part of this chapter, we will implement ASP.NET Core Identity as our identity provider, and later in the bonus section of the course, I will show you how to switch out ASP.NET Core Identity with Auth0. So that's it for our entity. Now a couple of more things that I added was extracting the types from the habit entity into their own files, which is why we have so many classes in the entity folder. I also added the respective DTO for our user and the user queries. In the database folder, we now have a user configuration, which configures a unique index on the email and identity ID columns because these values have to be unique within our system, and we want to have this constraint inside of our database. There's also our respective migration that will create the users table in your database when you start the application, so you don't have to worry about it. And there is also the users controller, which currently contains only one endpoint. This endpoint allows us to fetch the user based on their identifier, and inside of it I implemented a projection into our DTO. On the user DTO, we aren't exposing the user's identity ID because this won't be relevant for creating the user's URIs within our DevHabit application. So that's what I introduced when it comes to our new resource. In the upcoming lessons, I will show you how to implement user registration inside of our system, login, and then how to implement authentication and authorization using the user entity. Now a couple of more improvements that were made. We're standardizing our custom media types. So now if you open the habits controller, you can see all of the supported media types that this controller returns. This includes the standard JSON media type and our custom HateOS plus JSON media type. And I also made it explicit that you could use the versioned media types inside of this controller, but for some of them you may get an unsupported version response, which will return a 400 bad request. This depends on the API version that is supported for a given endpoint. Inside of the endpoints themselves, I also simplified how you check if you should include the links in the response or not. This is now a property of the habits query parameters, and I did something similar inside of our endpoint for fetching a single habit. I also simplified the logic for content negotiation when it comes to whether we should include the hypermedia links in the response or not. If you take a look at the habits query parameters, you will see that it's implementing a base type, the accept header DTO, which is going to bind from the accept header into a string property, and then there is a computed property returning a boolean on whether we should include the links or not. What this will do is parse the media type from the accept header and check if this value contains our HateOS subtype. If all of this evaluates to true, then we want to include the hypermedia links as part of our response. So now our check here becomes if the query include links is true, then go ahead and include the links in the response. The same also applies in our two getHabit endpoints. Here I added a strongly typed parameters object that contains similar logic inside, and I can just reference the include links property. I also made these changes in the tags controller, which now properly communicates which media types it produces, and also I added support for including hypermedia links in the collections response and when fetching a single habit. Here I'm directly using the accept header DTO, which I'm binding from the request headers to make a decision if we should include the hypermedia links in the response or not. So that's a quick walkthrough of what I built behind the scenes, and I think we can wrap it up here. In our next lesson, I will introduce you to ASP.NET Core Identity, which we can use as a lightweight identity provider for our DevHabit application. Welcome to our next lesson as we continue adding support for authentication in our REST API. As part of this lesson, I want to introduce you to ASP.NET Core Identity, what it is and what you can do with it, and we are going to set up the foundation that we need to work with identity from our DevHabit application. So what is ASP.NET Core Identity? It's a membership system and API that is natively available in .NET applications. It comes with a lot of built-in functionality out of the box. For example, you get user registration and login, password recovery, roles and claims-based authorization support for external login providers like Google or Meta, two-factor authentication, and much more. If you are using identity from an MVC application that has a user interface, then you can also integrate built-in screens for user management. Now, what is my plan for integrating ASP.NET Core Identity into DevHabit? I want to use identity for the heavy lifting when it comes to supporting authentication and authorization. For example, identity will take care of registering users. This also means properly securing passwords, hashing them, salting them, and persisting them in the database. Identity also has support for user roles, which is what I will use for implementing authorization, but I want to implement this in such a way that we aren't too coupled to our identity provider. I'll walk you through the specific decisions that I make along the way and explain why I'm making them and how they will give us more flexibility if we want to replace ASP.NET Core Identity with another identity provider. Now let's move into the code and set up some basics that we will need for using identity. The first thing we'll need to do is to create the respective tables that identity needs to function inside of our database. So for this, we will create a custom database context that we will only use for ASP.NET Core Identity entities. Now let's begin by creating a custom schema for these new tables, and let's call this the identity schema, and I want it to have a value of identity. This will help me implement logical separation between our DevHabit tables in the database and all of the identity tables that the framework will create. Now let's create our database context. I will add a new class and I will call it application identity DB context. This will be a sealed class and we need to implement some sort of database context. Now, if I just try to reference the identity database context type, you will see that this type doesn't exist. So we have to install an additional NuGet package. So let me right click my project and then let's try to find the NuGet package that we will need. I will look for identity and then start typing entity framework core, and this is the NuGet package that I want to install. Microsoft ASP.NET Core Identity Entity Framework Core. This will install the identity provider that uses EF Core under the hood for persisting our identity tables. So let me go ahead and install this. And now I can close this down and go back to my database context where I can now import the identity DB context type. Let's add a constructor here where I'm going to inject the database context options, specify my custom database context type, and then we're going to pass in these options to the base constructor. What else do we need here? I will override the onModelCreating method, which is configuring my base identity tables, so it's important to leave the call to base onModelCreating. This will wire up the built-in tables that we will need for identity to work, and what I want to do is to customize this after the fact. So let's set the default schemas to be schemas identity for all of the tables as part of this database context. And then if you want to customize the identity table names to match the snake case naming convention, you will have to add this piece of code. So for each of the identity tables or the respective entities, I'm going to update their names to use the snake case naming convention. I already have the naming conventions NuGet package which will take care of the properties on these entities, but I will have to take care of the table names myself. For now, this is all the customization I will need as part of this database context. The next thing we'll need to do is to register this database context with dependency injection. So let me go to the dependency injection class, and here I first want to register the database context. Inside of the add database method, I'm already configuring my application database context, and I can just copy this setup to configure my identity database context. So let's specify application identity database context. I wanted to use the same database, so I'm specifying the same connection string. I will update the migration history table to use the identity schema, and this will let me to completely isolate the identity tables from my dev habit tables in the database. And then let's create a new method in this class that will take care of registering our authentication services. So let's create a new extension method on the web application builder type, and let's call it add authentication services. I'm appending services to avoid conflicts with any existing methods that will be called add authentication, and you will see what these look like later. Now let's add our web application builder, and then I want to say builder services add identity, and here I need to specify my identity user type and my identity role type. I will use the default values, which use UUIDs as the primary keys. After I configure this, I also want to configure the respective entity framework stores, and here I can specify my custom database context. So let's return the web application builder, and this is all I want to do for the time being. Let's call this method from the program file, and for example right here I will say add authentication services. The next thing I want to do is to create an EF core migration for our identity database context that will scaffold all of the required tables in the database. So let me open up the package manager console. I will say add migration, then let's give a name to our migration. I will say add identity, and because we have two database contexts, I will have to specify which one I want to use for this migration. So I will specify application identity DB context, and I want to customize the output for this migration to be migrations/identity. I'll set the starter project to be DevHabit API and create this migration. And this is the migration that's created. If I open up the migrations folder, you will see in the identity folder I have my new migration file. Inside of the migration itself, we are ensuring that the identity schema exists, and then we're creating the respective tables, starting with ASP.NET Core roles, ASP.NET users, ASP.NET role claims, user logins, user roles, user tokens, and then all of the indexes that are required for this to work. So I will close this down, and then the next question is, how do we apply these migrations? Now we do have a helper method that helps us apply migrations when the application starts, but right now it's only taking care of our application database context. However, I can do the same for the identity database context. Now let me rename this, and then I will introduce another variable here that will be the identity database context. Now I will have to change the type to be application identity database context, and then I will just say identity database migrate async. Now let's separate the logs for these two. So let me copy the information statement I have here, and I will say application database migrations applied successfully, and below I will say identity database migrations applied successfully. And now when we start the application, the migrations for both of our database contexts should be applied to the database. Let's go ahead and start the application and confirm that this is working, and I'll place a breakpoint here. And you can see that my identity database context is resolved from dependency injection. So now I'm going to migrate the application database. This will succeed, and then we will migrate the identity database, which will also succeed. Let me press continue and move over into my database. If I open up my database from dbeaver and check out my schemas, you can see that I now have the identity schema with all of the respective tables inside, including a custom EF migrations history table. Inside of this table, we have just one migration that we just created, and if I take a look at the ER diagram for this schema, you can see all of our identity tables. The core table is ASP.NET users, which contains our users information, including the primary key, the user's name, email, and a bunch of identity columns. And we also have tables for roles, user roles, which is the table connecting the users and roles, role claims, user claims, if you want to assign a specific claim to just one user, Then we have user logins and user tokens. So this is the database structure that we will use to implement support for authentication and authorization. And with this, we're going to wrap up the current lesson about setting up ASP.NET Core Identity. I showed you what identity is and how to set up the identity tables inside of your application. In the next lesson, we will finally start using identity by implementing support for user registration.